Hello, everybody, and welcome to our Tuesday, September the 8th math lesson. Tuesday, September the 8th, our math lesson for the day is going to be lesson number 4, and the title of it is Multiplicative Comparisons. We're continuing our studies of multiplicative comparisons, and this one, if you hopped like a frog. Our I can statement for the day: I can identify and solve multiplicative comparisons based on a text and their own measurement data. Our essential questions are remaining the same, so we're building on that day after day. How can patterns within the number system help solve problems? That's the first one. And the second one, how are numbers related to each other? Yeah, we're doing a problem of the day. And our problem of the day is actually a question that was taken from our Unit 1 assessment. It was taken from our Unit 1 assessment on last week, because I think many people had trouble with it. So it says Zena wanted to find out whether students drink milk or orange juice most often. Which survey question should she use? And I'll repeat it. Zena wanted to find out whether students drink milk or orange juice most often. Which survey question should she use? If you see, they've got in big capital letters here, most, M-O-S-T. Got that highlighted basically to let us know that it's really important that you read and understand this word. And most often is what you're looking for. So she wanted to find out whether students drink milk or orange juice most often. Which survey question should she use? And our choices are A, what are your two favorite drinks? Does that really answer what we're looking for? So Zena is looking to find out whether students drink milk or orange juice most often. Which one does she drink the most often? Does this question answer that for you? What are your two favorite drinks? That doesn't tell us which one the students drink most often. So A is not going to be a good answer choice for us. Let's go to B. How many glasses of milk and how many glasses of orange juice do you drink at school? So how many glasses of milk and how many glasses of orange juice do you drink at school? So you've got, in this one, they're talking about milk and orange juice, and it's asking how many glasses do you drink? Is that going to answer the question of what Zena is trying to find? She's trying to figure out whether students drink milk or orange juice most often. She didn't necessarily ask how many glasses that they drink. So if she asked the question of how many glasses do you drink, this may be a good answer choice for us. But she's trying to find which one do they drink the most often. So this is not really going to give us an answer to that. Okay, so B is not a good answer choice. So let's go down to C. Do you drink more than a gallon of milk or more than a gallon of orange juice each week? Do you drink more than a gallon of milk or more than a gallon of orange juice each week? So is that going to answer the question of what Zena's trying to figure out? Whether students drink milk or orange juice the most often? So when you say most often, she really means how many times do the students actually go and drink the milk? How many times do they go and drink the orange juice? Not how much do they drink, but how many times do they go and do it? And this one is just talking about, do you drink more than a gallon of milk or more than a gallon of orange juice? That's not going to tell us how often they actually drink it, because a person could drink an entire gallon of one of these just one time. Just one time they could drink an entire gallon, possibly. All right, let's go down to the next one. How many times do you drink milk and how many times do you drink orange juice each day? Is that going to answer the question that Zena is really trying to figure out? So again, she wants to know whether students drink milk or orange juice most often. So in order for her to really find the answer to that, she needs to figure out how often do they drink milk, how often do they drink orange juice. And this question right here, how many times do you drink milk? How many times do you drink orange juice? That's going to give us the answer to that. So the most appropriate answer for this one is going to be D. D is the most appropriate answer for this one. On our next slide, we're going to talk about amazing animal facts. Now, the book that we read together just a couple of days ago was If You Hop Like a Frog. If You Hop Like a Frog. And we got a lot of really good, amazing animal facts out of that. What do you remember from that book? What do you remember from the book? Let's take just a minute for you to just think about some of the things that you remembered from the book. So some of the things that we discussed that came from the book was the fact that a frog can hop 20 times the length of his body. Fleas can jump 70 times their own height. A snake can eat something twice as wide as his head. And a spider can move 33 times the length of his own body in 1 second. So those are just some of the amazing animal facts that we got out of the back of that book. So let's take a look at our next slide, amazing animal facts. This part right here says, a frog can hop 20 times the length of his body. A frog can hop 60 inches. How big is the frog? And below that, fleas can jump 70 times their own height. A flea is 3 millimeters tall. How high can a flea jump? At the top, a snake can eat something twice as wide as his head. A snake's head is 4 inches. How large can his prey be? And at the bottom, a spider can move 33 times the length of his own body in 1 second. How far can it move in 5 seconds? So we're going to pause a second, and what I want you to do is just go back through and reread them to yourself, each one of them, and be thinking about, what do you notice about each one? What do you notice about each one? So you would be correct if you said, something along the lines of the fact that you notice that they all involve multiplicative comparisons. So they all involve multiplicative comparisons. So you either can use repeated addition or multiplication to determine the relationship to the facts. Okay, so for this one, I want you to go in and get a calculator. So if you've got a separate calculator that you can use, or if you've got a calculator on your phone, or you can use the calculator on the actual computer. If you're using a computer, you can use the calculator for that to help you with this. And there will be times where it's okay to use a calculator, and there will be times where I want you to solve the problems on your own. Okay, so for today's lessons, it's okay for you to use a calculator to help you. So let's take a look at the first one here. A frog can hop 20 times the length of his body. A frog can hop 60 inches. How big is the frog? So when you set this up, your equation should be 60 times 20. And when you use your calculator to get your answer, you should come up with 1,200 inches. Okay? So the frog is 1,200 inches right here. You're multiplying those. And let's take a look at the one below it. Fleas can jump 60 times their own height. A flea is 3 millimeters tall. How high can a flea jump? Okay, so just like above here, we got to do a multiplication. Okay, so back up to the first one. What helped me with the first one is the fact that I mentally used the cube strategy. But what I want you guys to really get in the habit of doing is when you have a word problem, after you read it, I want you to go back, circle all the key numbers here. Circle all the key numbers. So 20 times the length of his body. A frog can hop 60 inches. You got 60 inches right there. You're going to underline the question. Okay? So how big is the frog? I think we're missing a word right there. Okay? So key words or key terms that's inside of there, you got to think about, it says times the length. Okay, so that's a clue like we talked about previously. Times means that you are going to be multiplying. So let's go down to the second again. So fleas can jump 70 times their own height. A flea is 3 millimeters tall. How high can a flea jump? Circle my key numbers in here. 70 millimeters, 70 times 3 millimeters, and underline our question right here. And our equation for that one is going to be 70 times 3. Using your calculator, you should come up with the answer of 210 millimeters. Okay, so let's go on over to the next one. A snake can eat something twice as wide as his head. A snake's head is 4 inches. How large can his prey be? So this is a key term right here. Twice as wide. When you think twice as wide, you have to be thinking along the lines of multiplying by 2 or repeated addition of that number. A snake's head is 4 inches. Our question, how large can his prey be? So for that one, we are going to multiply 4, and I'll do it up here. 4 times 2, and you got 8 inches for that one. Okay, so let's move down to the bottom. A spider can move 33 times the length of its own body in 1 second. How far can it move in 5 seconds? So you got 33 times, 1 second, 5 seconds, and here's your question right here. Okay, so for this one, it's another multiplication. 33 times 5, and you should get 165. This one doesn't specifically say whether it's millimeters or inches, so I think a spider is going to be closer to an inch generally, so we're going to say inches. Okay, all right. So on our next slide, yes, again, you will be able to use a calculator. So yes, you can use a calculator on these. If you hop like a frog, this one's on page 47 in your binder, so you can follow along on page 47 in your binder. The first one, a frog can hop 20 times the length of his body. Average 4th grader's height, 52 inches. If I could hop like a frog, I could hop. I'm going to pause it, and I want you to set up an equation. Use your calculator to solve it. Okay, so for that first one, you should have 52 times 20, and using your calculator, you should correctly have the answer is 1,040 inches. 1,040 inches. So now we're going to go down to the second one. Fleas can jump 70 times their own height. Average 4th grader's height, 52 inches. If I could jump like a flea, I could jump. How far? I'm going to pause it, you to take a look at it. Use your calculator and try to solve it on your own. Okay, for that one, you should have, and it's a 7 right there, 70 times 52 equals 3,640 inches. Okay, 70 times 52 equals 3,640 inches using your calculator. The next one, chameleon's length is twice the size of its tongue. Average 4th grader's height, 52 inches. If I had a tongue like a chameleon, it would be how many inches long? We're going to pause, same thing. You take a look, try to solve it with your calculator. So this one's just a little bit different. This one is a division, and division is the inverse property of multiplication. 52 divided by 2 equals 26 inches. 26 inches for that one is the correct answer. And the last one here, a snake can eat something twice as wide as its head. Average 4th grader's head measurement, 20 inches. If I could eat like a snake, I could eat something how long? We're going to pause. Okay, so our answer here, using a calculator, 20 times 2, 40 inches is the answer. Our next slide gives our assignments for the rest of the day. You're going to do page 49 in your math binder. It's assigned to you on Google. Remember to take a picture of your work and upload it. Also, you're going to work on Dreambox. We want you to complete at least 5 lessons for the week. Okay?